Hello, welcome back for another edition of a free response question. Let's jump right into it. We are looking at question number 5 from the 2019 test. Um, we, if you're watching this as a random person, congrats for stumbling upon this video. We're about to do the whole thing. If you're watching this as a student of mine, we honestly talked about this problem at length in class, but I figured for the sake of thoroughness, I would still make a video, but maybe I'll talk a little less, but we'll see what happens. All right, let's jump right into it. Let R be the region enclosed by the graphs of g of x equals blah and h of x equals blah, the y-axis and the vertical line x equals 2. So here's the y-axis boundary, here's the x equals 2 boundary, and then which one is g and which one is h? This is a parabola, that's h on top, and this trig function, as you can see, is the bottom because it's got this little curve action, okay? So that's your trig. So find the area of R. All right, let's do it. So this is a non-calculator question. So this one's gonna take a wee bit of integration work here, all right? So to find the area, you simply, in general, right, you figure out your bounds, A and B, um, and then you're just simply gonna take the top function minus the bottom function and integrate that with respect to x, right? So that's what we got here, all right? So I'm not going to bother flipping up and down. I'm just going to look at the piece of paper here. So as we said, the top function is h. So in the context of this problem, from 0 to 2, right? Why 0 to 2? Because that's the beginning and that's the end of h of x, which is 6 minus 2 times x minus 1 squared, minus g, and g is negative 2 plus 3 cosine of pi over 2 x, all with respect to x. That's going to earn you a point, folks, right there. You've got the correct setup. All right. So lovely. Now, where do we go from here? We need to integrate. So take it piece by piece. This piece, this piece. Maybe distribute. Should we distribute the negative? Let's do that. Let's turn this into a plus, and let's turn this into a minus. Only because I don't want to like forget about it later, right? Because we're gonna need to do a little bit of number crunching here. I know I always say like stop doing the math, right? But the positive and negatives do matter, so I don't want to lose sight of that. I'd rather address it now. Anywho, let's integrate. The integral of 6 is 6x. The integral of this, we've got the constant's just chilling, but this is power rule, so that's going to go up by 1, and then we're going to divide by that power. And the derivative of the inside is 1, so you don't need to be concerned about like u sub or anything like that, all right? And then plus this integral of 2 is 2x. And then here, the constant's just chilling, and this is negative cosine. So the integral of negative cosine is negative sine, okay? So the integral of negative cosine is negative sine. So this is negative 3 sine of pi over 2x. And the derivative of the inside is pi over 2. So I'm going to divide by pi over 2, which is the same thing as multiplying by 2 over pi. So that's a little bit of a cheat code u substitution, right? I just simply divided by the derivative of the inside. That's not always foolproof, okay? That you can't just divide by the derivative of the inside. If you think that's true, you're wrong, all right? It doesn't always work out like that. But in the case, because the derivative is a constant, it does work out like that, right? It's a unique situation where the derivative of the inside is a constant. So the u substitution is more simple. All right, anyway, there's that. I do think that's worth dwelling on because some of us are still struggling on integrating. So at this point, you just need to plug in from 0 to 2. And honestly, you could try to do some math in your head, right? Like 6 times 2 here in a second is not that bad. But to be honest, it's just like, I don't know. Just you know what needs to be done. You're going to plug this in to x minus, and you're going to plug this in to x, right? And to be honest, if I'm your grader, I'm like, oh, I can see clear as day what this student is doing. They're not bothering to do any of the multiplying right this second, and they're never gonna do the multiplying or the trig or any of that because it's completely unnecessary. And why do what is completely unnecessary? Now, I wrote kind of big, so it went outside of the margins. Don't write outside of the margins on the test. But as you can see there, f of b minus f of a. Or, yeah, f of a. All right? Now, you can clean that up a little bit if you'd like, as you're maybe right there. But I'm just saying that's all that needs to be done. All right. Look at the scoring guidelines if you want to see the rest of that work. All right? Because I'm not going to bother writing it out. F of b. Or f of b. 5b. I'm in another world there. The region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis has an area of, find the volume of the solid. All right, this feels just like, if you watched the Riemann sum video problem before this feels exactly like part C. They told us the area of the cross sections and we integrated it. So let's do it again. We're going to take the, we're going to integrate the area of the cross sections along our region. The region begins at 0 and ends at 2, and you are integrating that area with respect to x from 0 to 2. Now, we do need to actually do this math, right? If it were a calculator question, I would just plug that in and we call it a day. But we're going to have to actually integrate, okay? So the integral of this is 1 over x plus 3. And the derivative of x plus 3 is 1. So anytime it's 1 over yada yada, besides nuanced situation where maybe you need to do a little more u substitution or something like that, for the most part, it's just this, right? And if you're like, what do you mean nuanced u substitution? What I'm saying is u equals x plus 3. So when I take the derivative of each side, I discover that du equals dx. Why is that true? Because the derivative of x is simply 1. So du equals dx. So when I u substitute, I get 1 over u. As we know, the integral of 1 over u is the natural log of u, absolute value. And what is u? X plus 3, right? So that's what I'm doing there. And then how do we solve this? You need to plug in the 2 and subtract, plug in the 0. And you're done. Now, of course, that part is not really that hard to mess up. So you could do that math if you wanted to have a nice, pretty final answer. But there it is. Natural log of 5 minus natural log of 3. If this integrating, if you're like, oh yeah, that is natural log, and you're like, oh yeah, that I do have to worry about. If you're saying, oh yeah, I forgot about that, oh yeah, I promise you, you're gonna forget it on the AP test. And if you don't want to, I know this doesn't sound exactly fun, but you need to drill and kill yourself with integrals. Drill and kill. Just integrate, 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 integrate. Drill and kill. All right? Because you can just search you know, AP Calc integrating worksheet, or not even AP Calc, right? Just like college calculus, right? Calc 1 integral worksheet, right? And just find a bunch of integrals. Are there going to be some that you've never seen before? Sure. Then just skip those, right? Like there are plenty of integrating things that we haven't done, right? There's integration by parts. There's, I mean, the list goes on. Trig substitution integration. Oh my God. So there's all kinds of integrating techniques that we haven't done, and you don't need to concern yourself with all of them, but you need to practice if you're saying, oh yeah, trying to do that. Oh yeah. We don't like the word oh yeah, right? Unless it's a oh yeah, and you're having a true aha moment. But if you're going, oh yeah, you gotta practice. It's not gonna just come to you. You're not just gonna remember the day of the test. You need to drill it into your mind. All right, part C, the last part. Write, but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 6. So here's the horizontal line y equals 6. 1, 2, 3, 4, 5, 6. All right. So there's this gap. You see the gap? If there is a gap, and especially from here to here, right? If there is a gap between your function and the axis, then you're using Washner method. So there is a little r and there is a big R. And when I say big R, I mean radius. And when I say little r, I'm talking radius. All right. So what is that radius? That radius is, in the case of little r, it's 6 minus the function, right? You're trying to find the distance between the line y equals 6 and the graph of h. The h is the top one, right? Yeah. So you're trying to find the distance between this line y equals 6 and the graph. So little r is 6 minus h of x. And the other one, you're trying to find the distance between 6 and g. So that's 6 minus g. If you're ever trying to find the distance of something, you're using subtraction, right? Distance is like a synonym for difference, and difference is a synonym for subtraction. Right? So you're just doing subtraction, and that will result in the radius. So little r of x, as we said, is 6 minus h of x, and big R of x is 6 minus g of x. So when you revolve a figure, you're doing pi times the integral of r squared. But because there's two r's, you're taking that big radius and squaring it, and then subtracting away the small radius. Okay? And this is the final answer because it said do not evaluate. Now, why does this make sense? Well, let me end with a comparison to geometry here. If you wanted to find the area of this circle, what would you do? Pi r squared. Would you not? If you wanted to find the area of this small circle, what would you do? You would do pi r squared. If you wanted to find the area of this orange region, what would you do? Well, you would take the area of the big one and subtract away the area of the small one because you want to remove this so that way you're just left with the ring. And that's exactly what we're doing in terms of volume. Pi r squared is the area of a cross section, a circular cross section. Cross sections that look exactly like this. But when you integrate those from 0 to 2, it's creating a volume. And thus, that's the right answer. Appreciate your time. Thanks for watching. It's always a blast. Bye.